C and C++, maybe a little? Yeah, there might be. Here we avoid that, right? Because the compiler actually and runtime actually keep track of what's going on, and you literally can't accidentally dereference a null pointer, not that this is a pointer. What's the other classic example in C and C++ of this kind of game? Well, nan, floating point has nan. Actually, in Rust, floating point nans are represented as nans because Rust floating point is kind of what it is. But I was thinking of something more obvious. If I call a C library function that's supposed to return, let's say, the size of a file, what does it usually return? A size t. What does it usually return if there's an error? Think back to your CS201. If you had it from me, especially, shame on you. What do C library functions tend to return on errors? -1. -1 is very popular, right? So you have this thing that is, well, yeah, but we're going to return this thing, but we're actually going to return -1 sometimes because something went wrong. That's a really popular source of bugs in your C code too, by the way, because if I have, it's bad enough for -1. So let's say that I index some array based on the number that I got back from the library routine. Oops, -1 is going to be used as an index. That doesn't sound very good. The only thing worse is maybe I turned it into an unsigned first, and now instead of -1, I have the maximum index possible. Ew. This doesn't sound happy. I wonder why C programs are so buggy. Here, I can't do that, right? I'm being very careful that I either return a floating point number or I say none. There was no floating point number. And it's the responsibility of the caller to sort that all out. You go, well, did I get a floating point number back or not, if the caller clears? This is the option type. There's also the result type, which we'll talk about later, which is sort of the fancy version of that. You're now getting a handle on what the Rust error handling story looks like. In Rust, we handle errors by returning error values. And we use Haskell style or Hindley-Milner or SML style disjoint union / sum type / thingies. We say, well, no. We always return a value. The value may indicate an error, but if it does, it's going to be a value of an error type, and so you'll be okay. Go kind of does the half version of this scheme. Go, the standard error handling scheme, which I think they may have just changed recently, but at least as of a year ago, Go's sort of standard error handling scheme is you return the value and an error, and so it's your responsibility as a programmer to check whether there was an error return, and if there wasn't, then you can use the value. Yeah, that's about as error prone as the C thing. Turns out to be a complete disaster. Here you have to check. You can't unwrap the value. You can't get at that value hidden inside the option without checking whether the option's sum or not. There's no way around it. And so you literally can't make a mistake. It will be caught at compile time. I mean, you can make a mistake, but it'll be a semantic mistake. You can't forget. Because if you forget, the compiler's like, hey, this isn't a number. This is an option. You can't use an option where a number is needed. If I try to add the result of mean to something, it's like, nope. Can't add the result of mean to something because it's not a number, it's an option number. You're like, oh, okay, I guess I should deal with that fact. The classic way to deal with that fact, in this situation, I know that mean will never return none. It says so right in the contract. Now, no is a super strong word here, right? What do I actually know? I know that some document promised me that mean would never return none. Can I really count on that? I don't know. Maybe the interface changes. Maybe somebody screwed up. Maybe there's a bug, right? So I can't really count on it, but I can count on it this much. I can, instead of writing the code this way, I could have written it as .unwrap. Unwrap is a thing that on an option, when given an option type, produces the value inside the sum. What if there is no value inside the sum? What if it's none? Well, then your program fails. So you should never, ever unwrap unless you're sure that the value you're getting is not none. But here I am. Mean's not supposed to return anything, right? So I'll unwrap, and If me never did return none, my program would panic when I tried to do that. Good, because something went horribly wrong inside my program at that point. That would be fantastic. I'd much rather have a panic at that point than some random port up or overwrite memory or produce wrong answers. These things all sound way worse like that. So that's unwrapped, and we've seen it some. It's kind of considered sketchy in a lot of situations, but this is a situation where you definitely just want to unwrap because you're definitely not ever supposed to get back anything but a sum value out of here. By the way, in addition to unwrap, there's a variant that's useful for debugging. I'm sorry, I don't know what just happened. I apparently can't operate my editor. There we go. There's a value called expect. Which, when it panics, will print the error message you put in there. People don't use that very much except when they're trying to debug programs because it's kind of pointless. When it panics, it's going to give you the line number. Here, I'll show you. Me and now will always return none. Yay us, go us. Oops, except that won't, because I bugged it somehow. Oh, I left it expected instead of that. Expected wrap. And it fails. Oh, sorry, let's just call. And oh, right, sorry. I don't have any good way to show this better, boy. But it would panic and it would print if you ever this test, if it were normal code, not test code, would panic and it would produce a line number that your panic happened at and that kind of stuff. It seemed to be enough to debug it. Plus, you could ask it to print a full backtrace if you want to try to figure out what's going on. So unwrap's usually sufficient. But I would probably write this like this a lot of the time. It's a matter of taste. I don't know. Put this back the way we found it. Put this back the way we found it, because why not? And off we go again. Actually, what we really should probably do is there. Now we put everything back where we found it. Git is your friend. So your job, obviously, and I think this is obvious, but I'll say it again, is to replace these unimplementeds, get rid of these, and instead put in code that actually computes the mean. Hopefully all of you won't have too much trouble figuring out how to compute the mean of a bunch of numbers. That should be good. But you may have to look up some of the others of these. You may not quite remember how to compute the standard deviation. That's fine, it's a thing you can look up on the internet. You may not quite remember how to compute the median. I gave you the first part of the median computation because it turns out sorting floating point numbers is a pain in the neck in Rust. Sorting, lists of floating point numbers is a pain in Rust sequences. Why? Why would it be a pain? Why do I have to do something weird? Why can't I just say nums.sort? What?
Ownership?
No, it doesn't really have anything to do with ownership. It's specific to floating point numbers. Anybody know their IEEE float's cool? Nobody knows their IEEE float's cool. That's fair. IEEE floats are a nightmare. Okay, here's the deal. We mentioned earlier NaN, not a number, right? I hope you've all watched the Watt video. If you haven't, you should go watch the Watt video. And in particular, you should see where he does the Batman theme in JS. Not a number is an IEEE invention, floating point committee invention. It's kind of interesting. It's kind of like a null for floating point numbers. It's this thing is not a number. Well, then why is it a number? Because it's a number, but it's not a number. Okay, fine. So IEEE floating point has normal floating point numbers, all the ones you'd expect to have. And it has infinity and minus infinity, which is a little weird. But you can represent those exactly as infinities. But what if I divide infinity by infinity? Or divide 0 by 0 for that matter? Pretty clearly the answer of 0 divided by 0 is not necessarily 0. Pretty clearly it's not necessarily an infinity. Pretty clearly it's not at all a normal kind of number. What is it? Well, IEEE decided it's not a number. Okay. And you would think at that point you'd just have your program crash. You just try to divide by 0, we have no idea what to do with this, just stop. But IEEE decided that for efficiency reasons, sometimes you didn't want that to happen. And Rust has let them take that approach because of efficiency reasons. And so instead what will happen is you'll get a NaN, a not a number floating point value. One of the rules of not a number floating point values is that they can't legally be compared with anything. Or more accurately, comparing them with something always is false. So if I say, does NaN equal 5? No, false. Does NaN equal NaN? No, false. You know, all NaNs are different. All NaNs are notionally different. But now I'm trying to sort a vector of floating point numbers. Well, ouch. As long as the vector of floating point numbers has normal floating point numbers, we're obviously good with our sort. Even if it has infinities in it, that's cool. Minus infinity sorts at the beginning, infinity sorts at the end, right? We're all good with that. But what about when I get a NaN? How do I sort those? Not at all obvious. So Rust decided in its infinite safety and wisdom to just not allow you to compare floating point numbers for less than and greater than inequality the obvious way. Instead, the floating point numbers are what are called partial ordered. That is, you can compare any two floating point numbers when one of them is not a NaN. And when both of them are not NaNs. And so here we see an interesting thing. What's that thing with the pipes and the dot? Well, that's a kind of function declaration. It's a lambda. There's nothing like it in C. There's probably something like it in C++, but I don't know the syntax. Java has things vaguely like this, but not really. Anyway, this is a little function that I'm going to pass to sort by. And the function compares two numbers to see which one's bigger. But it uses partial comp. Oh, but partial comp might not be able to compare, right? If A is a NaN or B is a NaN, then partial comp can't compare these legally. Guess how partial comp works? It returns an option type. It says, oh, you know what? I either return some comparison result or I return none. Notice the last part of that expression? Unwrap! We'll get rid of the sum. So what that means is that if I ever have any NaNs in the list of numbers I'm trying to sort by with this thing, what happens? My program panics. That sounds good. If I have NaNs in my array, I'm perfectly happy to panic when I try to sort them. Makes sense? But the reason I spotted you that code is it's like 3 minutes of explanation that I had to look up on the internet to remember the exact details. By the way, notice the thing I did there? Oh, there's a comment that says where on Stack Overflow you can find what I did. Please do that. I'm going to be doing it. You should do it too. Anyway, so that I spotted you that. I also spotted you the to-own because we haven't really talked about ownership yet. Anybody know why we need that let mute nums equals nums.toOwn? That seems like a really, really weird thing to write. Why would I want that thing? Nobody's got that far yet? Anybody? Cool.
somebody else's memory.
I not only don't want to modify somebody else's memory, I don't get to modify somebody else's memory. Excellent answer, right? The thing that's being passed in is a reference to memory. I don't have any right to modify that memory. If I try to, the compiler's like, nope. So, I can't take my pointer, which is what that thing notionally is, and sort the thing being pointed to. C doesn't let you do that. Will let you do that happily, right? And C++ will. They have this whole const game they play, but really it's only advisory. You don't have to pay attention if you don't want to. The worst that can happen is you'll get some compiler warnings. But here in Rust land, it will refuse to let you sort an array in place if you don't have the right to mutate that array. So I make a copy. 2owned here essentially makes a copy into a different kind of array that I can actually whack around. I don't actually have a pointer anymore. That once I say let me nums equals, I don't have a pointer anymore. I have an actual array of that. And I mark that mutable because I'm about to rearrange it all. I'm allowed to do that since I own it. That is an introduction to an introduction to an introduction to ownership right there. So I made sure first to make sure that you own nums and can mutate it. And then I sorted it because that's probably the next thing you're going to want to do. And then there's some other step to compute the actual median of this sorted array. Hopefully you can figure that last step out by yourself. Yeah?
I have two questions.
Mm-hmm.
When you say, like the first line here, let mutable nums,
Yep.
You're using the nums identifier and you're sort of overwriting what it's.
Yeah, there's two variables in this. They just both happen to have the same name, right?
Right.
There's the parameter passed in, which is named nums, and then there's this whole different variable, which I also decided to name nums. In a lot of languages, that's considered a code smell, and the compiler might emit a warning, shadowing outer declaration, blah, blah. In Rust, that's considered good form, because I'm never going to want to know about the parameter again once I've done this thing, and so I did that on purpose.
So you cannot access
The original parameter, yeah, because I don't have a name for it anymore after that. That's correct.
Okay.
Yeah, you got that perfectly. Second question.
Second, sort by takes one argument and it's the function that you're going to
The sorting
use.
function, yeah, exactly.
Okay, cool.
Exactly. I mean, it implicitly takes two arguments, right? Where is the second argument?
The first argument would be nums.
Yeah, the first argument would be nums, right? Rust isn't an object-oriented programming language. I keep using this syntax that looks like object syntax. That thing on the left, you can see it up there. It's not an object. It's just a thing, right? Rust sort of has this compromise game called traits, which we'll learn in week 4 or 5. But the basic notion of traits is that you can produce, well, in struct implementations and all this stuff, is that you can use the syntax where the thing to the left of the dot gets passed as the first argument, essentially, and that's pretty much the whole story of that. So you can really think of sort by as a two-argument function that takes the thing to sort and the function to sort it with. But, in better syntax. I think it's worse syntax, but a lot of people think it's better syntax. It's more comfortable for them. It also, the story's way more complicated than I'm letting on here, but that's the 5-second version of it. Yeah, both very, very good points. So that's the part you need to write. Let's look at the part just for that you don't have to look at really. Just to see what's going on here. Here's the thing that's actually going to call your library. Here's the binary program. I decided to just write this for you because I thought it's the first assignment on the first week. And by the way, we'll get away pretty much really fast from this whole I write code and hand it to you thing. I wanted to do it this first time. So there's a lot of interesting things going on in this code. Let's talk about a few of them as they come up. We start our program with a copyright and license information. Fantastic plan. I highly recommend this plan. Please follow this plan. I didn't actually mean to here. I did it by accident, but I'm fine with that. Use stood : process : exit : here is a separator for module path names, just like it is in C++, or Nickel, or any of 50 other languages. That says there's a library called stood. It's gonna be linked with your program. There is, it's the standard library, it's just like C is standard library, sorry. There's a module called process in that library. There's a function, well, a name called exit, which in this case happens to be a function in that module. You want to be able to use that without giving the path. Does that make sense? Absolutely nothing fancy there. Then we have a usage function. This is kind of an interesting function. First of all, notice what it does immediately. It uses the exit function to get out and exit your program. That exit here means exit your program, as you might expect from student process exit, with status 1. After printing a message, ePrintlin's like println, except it prints to standard error, no other difference. ePrintlen, this giant usage message and exit. What the heck kind of return type is exclamation point? Exclamation point doesn't really look like a return type to me. It looks like an exclamation point. Does Rust have an exclamation point type? Anybody know what's going on here? That's Rust's way of saying this function will never return. You need not worry about the return type of this because it don't have any. It's what it diverges. Its value is bottom. Its type is bottom. Blah blah. You pick whatever way of saying it you want in programming language world. This is a function that will never return, and sure enough, it won't because it's guaranteed to call standard process exit at the end. Fair enough? And that's nice because the compiler then doesn't have to worry about what will happen after that. So we go ahead and do this properly. Yeah.
Is there a void return type?
There is a unit return type. So that's a great point. So let's go jump on this. Let's make a function that doesn't do anything.